Hey everyone, welcome back to our C# tutorial series. I hope you're all enjoying the journey so far. In our last video, we took a deep dive into lists and learned how to use them to manage dynamic collections of data. Today, we're going to explore another incredibly powerful data structure in C#, dictionaries. Dictionaries are like the Swiss Army knives of data structures. They allow you to store data in key-value pairs, making it super easy to look up, add, or remove data based on a unique key. If you've ever had to search through a list for a specific item, you'll immediately see the advantage of using dictionaries. By the end of this tutorial, you'll know what dictionaries are, how they work, and how to use them to solve real-world programming problems. We'll cover everything from creating and initializing dictionaries to adding, accessing, and removing elements. We'll also dive into some of the most common methods and properties you'll need to master when working with dictionaries. So, grab your coffee, get comfortable, and let's jump into the world of dictionaries. Before we dive into the code, let's talk about what a dictionary is and why it's so useful. In simple terms, a dictionary in C# is a collection of key-value pairs. Each key in the dictionary must be unique, and it maps directly to a value. Think of a dictionary as an actual dictionary you might have on your bookshelf. You look up a word, the key, and the dictionary gives you the definition, the value. This is exactly how a dictionary works in C#. You provide a key, and it gives you the associated value. Here's where dictionaries shine. Fast lookups: if you know the key, you can retrieve the value almost instantly. Unique keys: each key in the dictionary is unique, so there's no ambiguity in finding the value. Flexible storage: you can store any kind of data as the value: strings, numbers, objects, even other dictionaries. In a nutshell, dictionaries are perfect for scenarios where you need to associate one piece of data with another and retrieve it quickly. Let's start by creating a dictionary. Just like lists, dictionaries are part of the system, collections, generic namespace, so make sure to include that at the top of your file. Here's an example where we create a dictionary to store the names and scores of players in a game. In this code, we declare a dictionary with dictionary string, int, which means it maps string keys to int values. The add method is used to add key-value pairs to the dictionary. Each player's name is the key, and their score is the value. A for each loop iterates through the dictionary, using key-value pair string, int to access both the key and the value. When you run this code, the output will be. Notice how easy it is to add data to the dictionary and then retrieve it. The dictionary automatically ensures that each key is unique. Next, let's talk about accessing and modifying elements in a dictionary. Unlike lists where you use an index, in a dictionary, you use the key to access the value. Here's how you can access and modify elements. In this example, we use player scores, Alice, to access Alice's score directly. To update Bob's score, we simply assign a new value using the key, player scores, Bob equals 45. The updated output will be It's that straightforward. The key is your direct reference to the value, making dictionaries extremely efficient for lookups and updates. Dictionaries are designed to be dynamic, just like lists, so you can easily add and remove elements as needed. We've already seen how to use the add method to insert key-value pairs into a dictionary. But what happens if you try to add a key that already exists? The dictionary will throw an exception because keys must be unique. To avoid this, you can use a safer approach. This code checks if the key Eve already exists before adding it to the dictionary. Removing an element is just as easy. You can use the remove method to remove a key-value pair. Let's see a full example. When you run this code, the output will be You've successfully added a new player and removed another. This kind of flexibility is what makes dictionaries so powerful. Dictionaries come packed with several useful methods and properties that make working with them a breeze. Let's go over some of the most commonly used ones. Contains key, checks if the dictionary contains a specific key. Contains value, checks if the dictionary contains a specific value. Try get value, safely retrieves a value without throwing an exception if the key is not found. Count, returns the number of key-value pairs in the dictionary. Keys and values, provides collections of all the keys or values in the dictionary. Let's put some of these methods to work. This code introduces a few more powerful concepts. Contains key helps you check if a specific key exists in the dictionary. Try get value allows you to safely attempt to retrieve a value without causing an exception if the key doesn't exist. Keys and values properties let you iterate over or display just the keys or values. This is just scratching the surface of what dictionaries can do, but these methods are among the most frequently used. Now that you've learned the basics of dictionaries, it's time for a challenge. Create a simple contact book using a dictionary. Your program should allow the user to add contacts with names and phone numbers. Display all contacts. Allow the user to search for a contact by name. Allow the user to remove a contact by name. Here's a skeleton to help you get started. Try to implement this on your own and see how you can leverage dictionaries to build a functional contact book. That wraps up our introduction to dictionaries in C#. We've covered what dictionaries are, how to create and use them, and some of the powerful methods they offer. Dictionaries are indispensable in many programming scenarios, especially when you need fast lookups and flexible data storage. Whether you're building a contact book, managing game scores, or handling complex data structures, dictionaries will often be your go-to tool. In our next video, we'll explore LNQ, a powerful feature in C# that allows you to query and manipulate data in a clean and expressive way. You definitely don't want to miss it. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell to stay updated. And as always, if you have any questions, drop them in the comments below. I love hearing from you, and I'm here to help you on your C# journey. Thanks for watching, and I'll see you in the next video.